Hello developers. Today we are diving into the world of functional programming. We'll explore what it is, how you can use it in Kotlin, and how it can improve your Android applications. So without further ado, let's start. Let's start with the definition of functional programming. Unlike object-oriented programming, which focuses on objects and their interactions, functional programming is a paradigm in which software is built by composing pure functions. Think of it like math. No changing data once it's set, just using functions that get results. It emphasizes immutability and avoids changing states and mutable data. To compare functional programming with imperative programming, we can say functional programming emphasizes declarative approaches or what to do through functions and immutability, while imperative programming focuses on step-by-step instructions or how to do, and mutable state. In another word, imperative programming tells the computer how to do things step by step, while functional programming focuses on what to compute using functions without side effects. Kotlin is a modern language with robust support for functional programming. Let's look at the basics of functional programming and how Kotlin greatly supports those paradigms. Let's start with pure function. A pure function gives the same output for the same input every time and doesn't change anything outside it. As a very simple Kotlin example, this add function gets two integers and returns the sum of them. This predictability makes pure functions easier to test and reason about. Next, we have first class and higher order functions. Higher order functions can take other functions as parameters or return them as results. They provide a powerful way to abstract and reuse code. This example shows a collection map higher order function which gets a transform function and apply it to all the elements. As you can see, Kotlin treats functions like any other variable. You can pass them around and use them as you like. Immutability. Once created, immutable data does not change. Instead of altering it, you create a new data. Collections in Kotlin are immutable by default, which is unlike many other languages. In this example, the list is immutable, and to add a new item to it, we need to create a new list, and the original list remains unchanged. This helps in avoiding side effects and makes your code more predictable. Let's not forget that even if a collection is immutable, it may still contain mutable objects inside which are not thread safe. Recursion. A function that calls itself is recursive. You can use it to solve problems neatly. Here we have the famous factorial example done in recursion. Closures. Closures capture the state from the scope they were created. In Kotlin, lambdas and anonymous functions can do this. In this example, the count state is created outside the lambda but is accessible inside. Tuples. In functional programming, a tuple is a piece of data that cannot be changed after it is created. One of the most basic tuples in Kotlin is pair. It contains two properties called first and second and is immutable. In addition to pair, there is a triple tuple that also contains a third value. In general, data classes are usually a good implementation for tuples because they provide clear naming. As in previous example, it's not immediately obvious that the 19 value represents the employee ID. Let's not forget that not every data class is a proper tuple. You need to make sure that all of its members are values and not variables. You also need to check whether any nested collections or classes it has are immutable as well. Now let's talk about functional programming advanced concepts and how Kotlin language covers them too. Function composition. It's about combining simple functions to build complex operations. In this example, the composed function composes add and multiply functions. Querying. Transforming a function that takes multiple arguments into a series of functions that take one argument each. Here's an example that might look complex at the first glance, since we normally don't do this, and I will try to explain it for you. The add is a queried function which takes a single argument a and returns another function that takes a single argument b and adds it to a. Based on this statement, the add2 is a higher order function which now has 2 as value for the a parameter. And invoking it by passing 3 to it gives us 2 plus 3 as result. Memoization. A common task when developing different types of systems or solving problems is finding a way to avoid repeating the same computation multiple times. If our function always returns the same output for the same input, we can easily map its input to the output, caching the results in the process. This technique is called memoization. Let's assume we receive multiple lists of integers, and for each list, we would like to print its sum. Looking at the input, you can see that the first 3 sets are in fact equal. So calculating the sum 3 times would be wasteful, and we can do it once and reuse the cached value for the other 2. Then we have lazy evaluation. It is about delaying the initialization until needed. Kotlin's lazy keyword takes care of it for us. The next paradigm is pattern matching. It is a feature in many programming languages that allows you to check a value against a pattern, and if the value matches, deconstruct it and extract the data. It simplifies the process of checking and extracting values from complex data structures, making the code more readable and expressive by defining actions to be taken for each pattern. While Kotlin doesn't have pattern matching like Haskell or Scala, but it provides similar functionality using when expressions. In this example, the when expression checks the value of object against several patterns, and if the value matches a pattern, the corresponding block is executed. Patterns can be constants, data types, or conditions. Lastly, we have monads. Monads are a powerful and abstract concept in functional programming that helps manage side effects and chain computations. They can be a bit tricky to grasp, but an example can help illustrate how they work. In Kotlin, we can use result type as a simple monad to handle operations that might fail. In this example, the safe divide function safely divides 2 numbers and returns a result. And the process function uses the result monad to chain operations and return a default -1 value in case of illegal argument exception. The arrow library is the most famous Kotlin functional programming library, which includes other well-known monads like either or option. Functional programming offers several benefits for software development, including Android application development. First, it makes your code more readable and maintainable. The use of pure function and immutability leads to code that is easier to understand and predict. Second, pure functions and immutability make it easier to test your code. Since pure functions do not have side effects, you can test them in isolation. And finally, immutability helps reduce the risk of bugs by ensuring that data cannot be changed once it is created. This makes it easier to reason about your code and avoid unintended side effects. There's also some practical tips and best practices when it comes to applying functional programming to your piece of software. Start with the small, isolated parts of your project to introduce functional programming. Use immutable data structures wherever possible. Leverage Kotlin standard library functions for working with collections and higher-order functions. And avoid side effects in your functions to make them easier to test and reason about. As a good reference book, you can refer to Kotlin Design Patterns and Best Practices Chapter 5, which is all about functional programming in Kotlin and has many examples. That's it. Please write in the comments what are your experience applying functional programming to your projects and if you have additional tips for other developers. Also, if you like this video, do not forget to like and share it with other Kotlin developers. Bye!